Okay, in this video, we're going to talk about how to tell if a data set is unusual or usual for a set of data. So this is known as the range rule of thumb. And for most data sets, and this is for if they're relatively normal or bell-shaped, the minimum usual value is the mean minus 2 standard deviations. So you use that little formula and that will tell you the minimum usual value. Anything below that would be considered unusual. For the maximum usual value, we're going to use the mean plus 2 standard deviations. So you'll need to find the mean and the standard deviation. If you just have a sample, our symbol will be x bar minus 2s and x bar plus 2s. So here's an example we'll work through. It says the following sample is made up of lengths of 16 randomly chosen phone calls in minutes made by employees at a particular place of business. So we're going to find the mean and the standard deviation of these 16 calls. So we're going to go to Stat and Edit and put these numbers in L1. I've already done so that you don't have to watch me do that on the video. So if you want to follow along, I would recommend pausing the video and then restarting after you have those numbers in L1. Then to find the mean and the standard deviation, we're going to hit Stat, use the arrow to go over to Calc, and hit Enter. We'll have L1 there, and just hit Calculate. So our mean here is 24, and our standard deviation is 11.5. So we're going to use that in the formulas we stated above to find the maximum and minimum usual values. So the minimum usual value would be, remember, x bar minus 2s. So it'll be 24 minus 2 times 11.5. So we can just do that in the calculator. So there we get 1. So anything below 1 would be considered unusual. And then we'll do the maximum usual value. So the mean plus 2 standard deviations. So 24 plus 11, or 2 times 11.5. So we get 47. So anything between 1 and 47 would be considered usual, and anything below 1 or bigger than 47 would be considered unusual. So when the question is asked, would it be statistically unusual for a call to last 3 minutes? The answer is no, because 3 is between the usual values of 1 and 47. Okay, we're now going to see how this relates to the normal distribution. So for the normal distribution, or for bell-shaped data, we have what's called the empirical rule. And the empirical rule tells us really how much of the data lies between parts when you go out from the mean. So for our bell-shaped data, we have the mean at the middle, and then we can go out by standard deviations. So if we go out 1 standard deviation of the mean, so that would be the mean plus sigma and the mean minus sigma. So we want to know how much of the data would be in there. And the empirical rule tells us that 68% of the data is within 1 standard deviation of the mean. So the mean minus sigma and the mean plus sigma. 95% of the data is within 2 standard deviations of the mean. So the mean minus 2 sigma and the mean plus 2 sigma. And 99.7% of the data is within 3 standard deviations of the mean. So the mean minus 3 sigma and the mean plus 3 sigma. 99.7% of the data. And this is actually where we get that usual unusual rule. Because remember we said something that is less than 5% probability is unusual. Well, here we're saying if you're within 2 standard deviations of the mean, you're within 95% of the data. Anything outside of that would be part of 5% data, which we would consider unusual. There's one other term we have here, and that's the variance. So the variance is another measure of how much values varied, and it's just the square of the standard deviation. You just take the standard deviation and you square it. So you do have to find the standard deviation using your calculator. So for a population, it's sigma squared, and for the sample, it's s squared. So let's find the variance for the data in example 1. So we'll go back to example 1, page 22. Okay, so if we put these values in, five, 8, 11, and 36. So to find the variance, we want to just put the values in, go stat, calc, one variable stats. And this was just a sample, so we're going to take the S value, 14.2126704, and we're going to square that. Oops, I wasn't typing. And we can round this final answer, say to 2 decimal places, which would actually round it up to 202. So you just take the standard deviation and you square it to find the variance.